Hello. In this video, we're going to discuss the meaning of the coefficients for graphing sine and cosine, but specifically the effects of A and K, which will affect the vertical changes for a graph. And when I say A and K, I do mean this right here, where the amplitude is the absolute value of A, and then here the vertical shift is K, which moves the entire graph up and down. The amplitude gives us the distance of the max or min height of the wave from the axis. So let's take a look. Now also I am making the assumption that for both sine and cosine, you are really familiar with the basic shapes. So what do I mean by that? I mean that if you look at the unit circle and you go around the unit circle, that you're really familiar that, for example, for y equals sine x, that basic shape, you really understand that for y-axis, here x, this is, let's say, positive 1, and here is negative 1, that as you're going around the circle, so in this case, if I start at 0 and I go to pi over 2, then I go from, let me make this axis 2, that basically I'm going from here, 0, 0 is this point, starts at this angle, and then as I rotate toward pi over 2, I'm going to go right up to the max. And then, as I go from pi over 2 to pi, I create this, from pi over 2 to pi, this part of the sine function. And then when I go from pi to 3 pi over 2, then I go to the min. And then when I go from 3 pi over 2 back to 2 pi, I complete the cycle by going like that. So that when I draw my wave, generally what I'll do is I'll know very well in my mind that I do this. I go ahead and put my dot here, then I go to a max, then I come to the 0, I go to the min, and I go back to the 0, or the axis. And then I fill it in. So I am really familiar with that. And for cosine, right, as I go from 0 to pi over 2, and then to pi, to 3 pi over 2, and to 2 pi, I know that I start out at a max, then I go to the 0, then I go to a min, then I go back to a 0, and then I go back to a max, right? And that's happening as, so this part from here to here is this first part. Then as I come this way, that's this part. Then as I do this, that's this part. And then finally as I complete it, that's this part. So again, I'm assuming you know this very well, and you need to, or else you need to go back and review these basics, or else the rest of this is going to be too hard. Okay? All right, with that in mind then, let's do a few examples to look at. When you look at, for example, sine of bx plus c plus k, we're just looking at these effects. So all of our equations will have 1 as a coefficient for b and 0 as a coefficient for c. Okay? So we're just going to be looking at something like that. And they may not even have parentheses here because you really don't need them. All right? So let's take a look at, for example, y equals sine of x plus 4. So understood, again, in your head, you're writing this. 1 sine x plus 0, or 1x plus 0 plus 4. Right? So you know a is 1 and k is 4. So how do I do this? Well, essentially, I go ahead and draw my axes. I know there's no change, no horizontal changes, because b is 1 and c is 0. So I know I'm going to have my full wave from 0 to 2 pi. But I have vertical changes. So one thing I know is the k is the new axis. I go up 4, and I go ahead and dot a little line for myself so that I know, oh, that's my new axis. Whereas before, sine used to wrap around y equals 0, now it's going to wrap around y equals 4. And in this case, the coefficient of a is 1, so it's just going to go up 1 and down 1 around this axis. So I'm going to say here, I'm going to start at the 0, then I'm going to go to the max, I'm going to come back to the 0, I'm going to go back to the min, and go back to the 0. Notice I didn't even pay attention, I just go up 1 and then down 1, because that's what sine x does. Okay, so then I just fill it in. All right, that's y equals sine x plus 4. And it would just continue on forever and ever in both directions, same idea. So I would do 2 pi to the left and 2 pi to the right and draw the same shape. Okay? All right, so let's look at a second example. Suppose we look at going the other way. So here, oh, and by the way, let me just mention here, this could have been written y equals 4 plus sine x. It would be the exact same thing. Okay? So again, here, this could have been written negative y equals negative 5 plus sine x. Okay, so just realize there's different ways of writing it. But in this case, I would, in the more standard form, I'd write 1 sine of 1x plus 0 minus 5. So that I recognize a is 1, and then k is negative 5. And of course here b is 1, c is 0. Okay, so to draw this rather quickly, again, I go from 0 to 2 pi. There's no horizontal change. And notice I'm always dividing the interval from 0 to 2 pi into fourths because, again, every fourth of the way something's happening here. This is the first quadrant, second quadrant, third quadrant, fourth quadrant, and that produces 1 quarter, second quarter, third quarter, fourth quarter. Okay? But in this case, I'm going to go down 5. 1, 2, 3, 4, 5. Draw my new axis. And again, the amplitude is 1, so I'm just going to go up and down 1 from here. I'm going to draw a regular sine function right in here. I start at the 0, I go up 1, go back to the 0 or the axis, come to the min, go back to the axis, or 0. And just fill it in. And again, I would just keep going, blah, 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 that kind of thing. Oh. So let's look at another example. Suppose now we look at y equals 3 sine x. Well, filling everything in, I would have 3 sine 1x plus 0 plus 0. So my axis is still 0. There's no horizontal change. The only thing that's happening is I'm going to be stretching from the axis up 3 and down 3. So a is 3. I'm going to go from 0 to 2 pi. Now, the difference is before I used to go up 1 and then come down 1, but now everything is being multiplied by 3. So instead I'm going to go up 3 and down 3. Okay. So this is still the axis I'm wrapping around, but now I'm going to start here at the axis. My max is now going to be 3 times what it used to be. So 3 times 1 is 3. Then I'm going to come back to the axis, and then I'm going to go down to the min, negative 3, and then come back. All right, and again, it would continue on forever and ever and ever. All right. Let's take a look at another example. Okay, so this would be written in its standardized form. So again, there's no vertical change in axis. The axis is still y equals 0. No horizontal changes, but there's a compression. Okay. So what that means instead of going up 1 and then down 1, if this had been 1, now we go half as much, so to a half. We'll wrap around. So here I start at 0 at the axis, go up to a half instead of going up to 1. Come down to the axis, go down to a negative half, come back up. Okay? And again, goes on forever and ever. And finally, example 5. Oh, actually, I'm going to do 6 examples. Y equals negative 4 sine x. So you can see here what happens with a reflection. All right. So again, if I write this in the standardized form, no horizontal change, no change in the axis, but instead of going up 1 and down 1, now I'm going to go 2, 3, 4. Extend that. I guess I should have done that as 1, 2, 3, 4. All right, so now what happens is instead of starting at 0 and then going up 1, we're actually going to start at 0 but then go down 1 because this is reflected. We're going to go down 4 because we're going reflecting it and going and stretching it 4 times as much. So I go here, I go down to the -4, come back to the axis, go up here, +4, and then back to the axis. So here we are. And there you go. And of course, it would continue on forever and ever, that kind of thing. And now the last example. Okay, so I would rewrite this again in its standardized form. So this is a 1x plus 0 plus 7. Okay. So we have an axis change. Our axis is now y equals 7, so my sine function is going to wrap around y equals 7, and it's going to get compressed to a half, and it's going to be reflected. But there's no horizontal change. Since there's no horizontal change, I can still do my horizontal axis divided in fourths from 0 to 2 pi. Okay, but now I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. Draw my new axis. Okay, and then this would be 8. Now, so my sine function, if this were just a 1, I would go up. I start here at the axis, go up 1, then come back to the axis, then come down 1, and then go back up to the axis. But now I'm going to be reflected and compressed. So what's going to happen is I'm going to come down instead of going up, and I'm only going to come down to a half, about here. Then I'm going to go back to the axis, then I'm going to come back up, but only about halfway, and then come back to the axis. So this is going to be what I'll get. Okay, and this would go on and on forever. Okay, thanks for listening.